Good afternoon, doctor. So this is my lab 2, and I'm doing the question 1 first. So this is here, you can see the codes, and here is the variable 1, variable 2. Then this is the code segment. And first of all, we need to build this code. Build. Okay, succeeded. Then compile. Then we're going to debug. Step over. So we can see from here, this is the memory part, the disassembly, watch 1 and autos, and this is the registers. So first of all, let me debug again, step over. Okay, so from the first line, you can see that it is going to save the variable 1, 9 or 1 into AX. So step over again. So from the register part, we can see the EX has changed to 0001. Then from the autos, we can see AX is 0001. So step over again. So for, the second line is going to save the variable 29 into BX. So from the register, we can see the BX has changed to 0009. And in autos, it shows the value BX is 0009. Then debug, step over again. For line 3, we can it shows the instruction is to exchange AX and BX. So in the register, we can see just now AX is 0001 and BX is 0009. So they've exchanged 9 and 1. And in the autos, we can see also AX has changed to 9, BX changed to 1. So debug again. Step over. The next line, line 4, is going to move AX to variable 1. So there are nothing changed in the register AX and BX, but we can see in the autos, variable 1 has changed to 9 as it changed, it moved AX, just now it's 9 into variable 1. Then next line, step over, line 5, the variable 2 in autos, we can see variable 2 has changed to 1, just now it's 9. So yeah, this is the end of question 1. Yeah, it exit now.
Morning, doctor. I'm answering email of Changjia, and now I'm going to represent the LAB2 question 2. So here is my plot. This is the data part. We declare 4 variable and declare it as double word data type. The below one is my code part, and here is my main program. So now let's compile it. It shows us it, then we continue with build. After this, we proceed to debug by step over. Okay, now there are 5 parts in my screen, which is memory, autos, wash, register, and also disassembly. So now let's execute one by one. So for the first line, the operation is going to move the x variable to EX. X variable is 40, and here we convert it to exa, it becomes 1A. So EX now haven't been declared anything else. Let's execute it. We can see that EX now is changed to 1A. And next, this operation is going to negate the EX. We negate it with 2 complements. Yes, so after execute, we'll see the values now have been negated. The third line is move the y variable to EBX. The y val is 1E right now because also convert from 30 decimal to hexa. And we can find that EBX now haven't been declared. After we run, the EBX will be value 1E. The line 4 is going to subtract EBX with Z bar. We can watch that here. Z bar is 40. Okay. After we subtract, we will get this value. And next is adding operation. We will add EX with EBX. We can focus on this part. Yeah, as you can see, the value has increased because of adding the EBX just now. And let's proceed to the line 6. It's going to increase EX with 1. So here's DC. And after we execute, you are adding 1. It is from D, it is from C, increase to D. And the line 7 is going to move the EX register to the R bar value. So we can see that R bar is 0 here because we didn't initialize it at early. So after we run, the R bar will become the value of EX. That's all for question 2. Thank you.
This is the question for lab 2, question 3. So first of all, this is the data part, and here is the code segment. So first of all, I will compile this project. Succeeded and build. Now we're going to debug. So step over. And we step over again to see the result for the first line. Debug, step over. Okay, so for the first line, you can see you want to move variable 1 into EX. So variable 1 is 5. So the EX now in the register, we can see EX now is 5. And same to the autos, EX 5. So we debug again to the step over again. So for the line 2, it wants to multiply the variable 2. So we need to change the variable to 10 and in decimal to hexadecimal. So for 10, the hexadecimal is 8. So it's going to multiple A with 5. So the multiplication is 32. You can see in the register, EX now is 32. And in autos, EX is same 32. So now we're going to debug to the line 3. Step over. Now the instruction wants to add the EX with variable 3. So it will change the variable 3 decimal 20 to hexadecimal, which is 14. So 14 is added to the 32 just now. 32 the multiplication that's saved in EX. So after the addition, the register will show 46, which is 46. So same to the autos, EX is 46. So debug again, step over to the last line, which is -1 from the EX. So just now the EX is 46. Now we can see in the register, EX now is 45, which has already -1. So this is all from lab 2 question 3.
Now I'm going to present the LAB2 question 4. Here is my part, my code part. Here is data part, which got 3 variables, var1 to var1, var2, var4, and they are declared as word data type. And here is my main program part. Let's compile first. After it shows succeed, we continue with build. After build, we proceed with step over debug. Okay, now for the line 1, the operation is going to move the bar 1 value to x. Bar 1 we got 28 right here. The 40 here is with the decimal value, and here you will directly convert it to hexadecimal, so it's 28. So after we execute it, you can see that our EAX will become 28 at the AX part. Okay, so the line 2 is move the 5 value to BX. The BX now didn't declare anything, so let's execute it. You can find that is turned to 5 value right now. And the third line is going to multiply BX. The BX is going to be the multiplier, and the multiplier will be the AX. The result will be stored at AX, and if there are some overflow value, we are going to store in DX. Let's execute it. So we can find that AX will change to CX, and DX will become 0, 0 because there are no overflow bit. The next line is going to move the var2 to BX, sorry. So the var2 now is A. So we run, you can find that it's changed to A right now. The line 5 is subtract the BX with 3. So we can focus on here. Yes, we can find that there's A, subtract 3 will become 7. The line 6 is going to divide the BX, is divide the AX with BX. BX will become the divisor, and AX will become the dividend. So the value will store at AX and DX. For AX, it will store the quotient, and the DX will store the remainder. Okay, yeah, they make some change here. This will show that after the operation of division, there are 4 remainder here, and the quotient is become 1C. The line 7 is move the AX value to var 4. Var 4 right here is 0 because we didn't initialize it early. So after executing it, the var 4 right now got value, which is AX also value. That's all for question for X.
Hi, so now I'm going to explain about LAB2 question 5. So first of all, we compile this project and build, succeeded, so we don't debug. So I've explained every line of this code. So for the first line, it's going to clear the move 0 to dx. So it means clear the dx. So we can see that in the register, the edx is 0, 0, 0, 0. So then for the next line, debug for the next line, for line 2 is going to move 1000 h hexa into ax. So we can see that in the ax, it has changed to 1000 hexadecimal, same to the autos. Then now to the next line, debug to the next line. So in this line, it's going to move 25 hexa into CX. So in the register, CX here has changed to 0025. Then step over to the next line. So the last line is going to apply AX by CX. So in the register, we can see that because it needs to save in AX and DX. So the answer for the multiplication is 25000. So the 2 is going to save in DX here, and the 5000, 25000, the 500 is going to save in EX here. So the final answer is actually 25,000. So from the DX first, so 25000. So this is the final answer we're going to get. So that's all for question 5. So I debug again to stop debugging and exceed. Yeah.
Now I'm going to present the question 6 of the LAB2. So here is the code provided in the manual and the question. So let's do it first. Let's compile it first, then do it. And we start to debug by self. Okay. So for this line, we are moving 0 value to dx because we want to clear the dx from the 16-bit dividend in this format, dx and ax. Okay, so let's move it. You can see that it's clear already. And next is we are moving x03 to ax. We love it. And the next step is we are moving 10 hexadecimal to DL. And the last step is we are divide the AX with DL. The DL is become the divisor, and AX will become the dividend. You can see that the result will be here. X0 will become the quotient, 03 will become the remainder. While you are still here, you can refer to this picture. Found that the divisor is BL, right? BL is 1 byte. It also means that it's a bit. So for the 8-bit, it's carried with this information. And the quotient was stored in AL, and the remainder was stored in AH. So here we call the done rex. You can find it. That's all for question 6.